Sorry about that.
There you go.
There we go. Can you guys see my calendar?
Not yet.
Nope.
Just a
one.
there you
Yeah,
go.
there you
There we go. Can you guys see my virtual machine?
Yep.
Yeah.
Okay, very, very good. Okay, let me maximize this. All right. That was a bit of a risk, but it's fine. Okay, can you guys see all of the different Blob tools that are on the screen?
Yeah.
I'm clicking on them and so on. Okay, what the Blob tool basically does is you tell it what to do and it's going to do that. It doesn't have one specific purpose that you're going to say it does. Like, it's not like a barcode reader tool that obviously reads barcodes. It's not a data matrix verification tool which reads data matrix codes, or OCV that reads characters. What Blob means is just something that looks for, you know, an unidentified looking shape. You know, you just tell it, okay, find me things, and it's going to find these things. So let me open one of the Blob tools so you guys can understand what I'm talking about. So the segmenter tab, what it's going to do, it's going to segment objects in the image. What you tell it to do is you're going to choose a polarity. You're going to tell it, I want to find light on dark objects, or I want to find dark on light objects. And then you give it a threshold between 0 and 255. And what it's going to do, it's going to find all the pixels within its region of interest that are either brighter than this value, if you choose light on dark, or darker than this value if you use dark on light. That's the first basic rule that it does. And this is what it's going to do. And then you go to the pre-filter tab. Within those pixels that it finds, it's going to, you know, lump ones that are connected into blobs. That's what Blob tool is basically called for, because it's going to get all those pixels. If they make one, if they're all connected, they will create a blob. And what it's going to do with the pre-filter tab is that you're going to tell it which of these blobs is it going to keep by giving it a minimum and maximum value within which it's going to take everything else out and keep the ones that fit within this pre-filter. So, for example, in the tool that we're looking at right here, it's going to keep blobs and pre-filter them with an area where if the blob is between 50 and I guess that's a million? Yeah, between 50 and 1 million pixels, it's going to keep all these blobs. Any blobs that are smaller than 50 pixels are going to be ignored and not taken into account. Anything that's bigger than 1 million pixels, it will be ignored and won't be taken into account. Are we all together?
Yep.
I feel like I'm in a class. I'm not supposed to do that. I'm sorry. Okay. The sort tab is hardly ever used, but it's used in situations where you're not just finding things, you're actually verifying that the things that you're finding are the correct things that you're supposed to be looking for. Like if you're looking at a set of tablets, for example, that's the first thing that comes to mind. If you're looking at 6 tablets, 3 in each row, each tablet has a specific size, the sorting function will give the tool the capability of having a specific size and shape and position for each one of those tablets. So it's not doing a random search, it's actually sorting each blob that it finds and knowing which one it's supposed to be and doing an inspection on each one of these separately. And it will pass if all of them pass and fail if one of them fails. The constraints tab is the one that defines the criteria with which the tool will pass or fail. There's a lot of different criteria here, from angle to area to bounding size to elongation, holes, blah, 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 total area, percent total area, and total blobs. So if you don't have any of these constraints checked, that means that your tool is just going to find things but not pass or fail. For the tool to actually pass or fail, one of these criteria needs to be checked. In the example that we have, what the tool is doing is it's going to pass if it has the exact number of blobs that it was trained on, because it has a zero tolerance in both the positive and the negative. Now, the constraints tab is very important to understand because the tool doesn't pass or fail based on giving it the specific values with which it passes or fails. You give it a tolerance from when it was trained. So if you trained it on 3 blobs and it needs to always find 3 blobs, you check the total blobs to be a constraint, and then you use a positive tolerance of 0, a negative tolerance of 0, and you train the tool when it has 3 blobs. If it has 4, it fails. If it has 2, it fails. Now, if you want it to be so that if it has 3 or 4, it passes, and you trained it when it has 3, you set your positive tolerance to 1. That way, if it finds 3, it passes, and if it finds 4, it passes. But if it finds 5, it fails, and if it finds 2, it fails. So the way the tool passes or fails is based on positive and negative tolerance values. And because of this, you need to know exactly what you're training the tool on, and the criteria with which it's being trained on is how these positive and negative tolerances are going to be calculated. It's something that everyone needs to understand. It's not like you're going to set the ranges from here. You're going to set the ranges based on a difference between what was trained and what you have on the screen. Does that make sense?
Yes.
Okay. All right. The stats is going to give you the statistics of the blobs that the tool is finding. This is sometimes very important if you want to use those stats to find out what's supposed to pass and what's supposed to fail and what the blobs that you're finding look like. Tool info is the same as any other tool. You got the name, you got the always execute option. It has only one result line, whether the blobs conform to the rules that you gave the tool or not. So let's zoom in a little and then and figure what's going on. Figure out what's going on here. Let's take a look at this blob tool that we have. And first of all, what I'm going to do is, I think there's a mask somewhere, which is, all right, blob. All right, let's take a look at this one. So this blob here, this blob tool is looking for bright objects because it's doing light on dark, and it has a fixed threshold of 155. That means that pixels that are brighter than 155 are going to be found. However, if these objects are smaller than 50 pixels in area, it's not going to be picked up. So one of the first things that we're going to, let's see what the tool finds if we take this off. So once we took the pre-filter off, what the tool is now finding are just small objects. One of them is right here. I don't know if you guys can see it. Let me turn maximum. Yeah, just tiny objects here that happen to be really bright. And I'm thinking one of the other things, that's the count tool, that's the script tool, that's the blob tool. What am I doing? Okay, sorry. All right. And I changed the light on dark. So can you guys see that once I turn the threshold down to 55 pixels, it's now finding a lot of stuff that's outside. Now, let me note one thing though. What this tool is also, what's also happening to this tool is that it's being masked from the center area. We have a helper tool called mask sometimes that can be used to hide areas that the tool is going to intentionally not look at. What mask tools do sometimes is that if when you have a shape like this and you want to find out defects outside the internal area, you use a mask that masks out that inside area so it only finds blob outside. Now, as I increased my fixed threshold, it's going to start weeding out some of these areas that are not so bright. There you go. So by nature, any of those areas that are outside this central pocket where this patch is are going to be found, but now it's finding things that are much brighter than what we had. I think the fixed threshold is 155. Let's keep going. And at 155, it only finds this. Now, obviously, what this tool is doing is trying to find objects that are supposed to be defects. I imagine they're looking for things like pieces of glass, bright objects that are not supposed to be in the neighboring area of the pocket where these things are. Let's take another big look at this whole thing. Now, imagine this is a web of pockets, with each pocket having a patch in there. These patches, as far as I remember, are like one of those, what are they called? Smoking patches, like people use them to try to stop smoking, and they come in these things, and we're seeing the object from behind with a backlight. And we're checking the integrity of the plastic that's holding this by looking for bright objects as well as dark objects within these pockets. So we actually have two different blob tools here. One that's finding bright things like white objects, like pieces of paper and things like that. And one that's actually trying to find dark objects within this area as well. So if it finds a random torn piece of the patch that happens to be in the area outside the pocket where the patch is supposed to be, it also detects that. So it's a very simple, basic inspection, but the idea is that you're going to have a blob tool that's looking for defects. So what it's supposed to find is always going to be 0 blobs. So to do an inspection like this, basically you set up your tool so that it sees the defects that you want it to see, and then what you train it on is going to be an area that actually has no defects. You train it on this, you tell it, do an inspection on total blobs. And if you find 0 blobs, you pass. If you find anything else, you fail. And that's why the tool right now is failing. You see the red borders out there. It's finding 7 blobs, 7 really tiny blobs. That's happening because we got rid of the pre-filter. And based on the constraints where we're saying in the total blobs, you have no tolerance. If you find anything that is not what we trained you on, if the total blobs is different from what it was trained on, which is 0, it fails. Once we turn the pre-filter on, what the tool is going to do is it's going to get rid of any of those little blobs that it's seeing that it wouldn't normally see. Let me bring this back to its proper position because it's supposed to be here. All right, so it's finding 12 tiny blobs. You can see some of them are over here. They're really, really small. And obviously, pre-filters you're always going to find pre-filters in blob tools, because if you don't filter out really tiny things, it might find a single pixel or 2 pixels attached to each other that are within this criteria. But the idea behind pre-filters is that you're going to tell the tool to not really care about small things that it might find, which can be noise, it can be a little piece of dust that really doesn't matter. It only matters if it's big enough. So that's why pre-filters are always used. I will check the area pre-filter, and now it doesn't see anything. Now the tool actually has turned green, and it's in passing mode because it's not finding any blobs. That's the very basic way of using the blob tool, is having it find things and telling it what it needs to filter from things that it finds by using the pre-filter, and then giving it constraints based on that. Now, the constraints sometimes used are total blobs if you want it to find a specific number of things or you want it to not find anything, and that's why it would pass. There's other modes of using the blob tool like total area or percent total area where you're verifying the presence of an object or text or a label or anything by having the tool find things that are supposed to be on this object, and if it finds enough of it, it passes, and if it does not find enough of it, it fails. So let's take a look at what we have here in total. We have 8 different lanes. I hit this button. Now this inspection is doing a whole lot of things as well. It's not just verifying that there's no defects around this area. It's also making sure that there is one of these in each. There's a little count tool in there that's supposed to find the entire patch, and if it finds one patch, it passes, and it needs to be within a specific size. So this is doing that as well. There's 4 different edge detection tools that are finding the left, right, top, and bottom edge to inspect for the height and the width of these patches, and if it's too short or too long, it fails that too. So there's a whole lot going on here. But I thought this would be a good idea for you guys to see what blob tools basically do. Now this is the most basic application of blob tool that does not need to use any morph filters. We're going to take a look at an example that does that. But before I move on, does anybody have any questions related to the operation of the blob tools here? Rachel, do you have any questions?
No, I'm good. Thank you.
Ben?
No, we're good.
Connie? McCarl?
No question.
Okay. Okay. So it's fairly easy. However, it can be complicated based on the application that it's being used for. So let me show you one of these. Let's do something crazy here. Okay. Yep. Okay. All right, let's open up an image from the evals drive. Okay, vision training. There we go. Okay. Let's open the same folder, figs. Okay. Carton contents is an inspection that happens maybe a couple of times a year, and it's always they're all unique. All the carton contents inspections that we see are generally very different from each other because it always depends on what's going to be in the carton. And even though this might be similar to a lot of other cartons that we see, the method for which we use the tools is always going to be somewhat different. And blob tools are a lot of times the primary tools that's used to do this. And when we do carton contents inspection, we like to have a tool that verifies the presence of each component that's supposed to be there. So in this example, we have a tool that's verifying the presence of the bottle. There's another tool that verifies the presence of a syringe with a white cap. There's another tool that finds the presence of the leaflet. Now, since we're talking about the Blob tool, it's also important to understand the count tool. The count tool is basically an easier version of the Blob tool. The count tool is very simple. It has only two tabs. It has a setup tab where you tell it everything that you need, and that's it, and the tool info tab, which comes with all the tools. Now, what the count tool does is that you give it a minimum object size, you give it a maximum object size, so that's your blob size pre-filter, similar to what's in the Blob tool. You give it the polarity, light on dark or dark on light, and you tell it the expected object count. What the count tool does is that it works in that sort of simplified mode within the Blob tool that it's already counting blobs. The Blob tool is more flexible, where it can be used for other things than just making sure that the correct number of blobs is there. So a lot of times we use the count tool as well if we're making sure that there is one of this object or two of this object or whatever. And here we set up the polarity based on the object that we're looking for. We tell it what the minimum object size, what the maximum object size is, and we tell it the expected count. So this is similar to using a Blob tool and telling it that your constraint is a positive tolerance of 0 and a negative tolerance of 0, and it's trained with a single blob. Okay, so this particular count tool, it doesn't have any morph filters on it. What morph filters are used for is that they change the way that the actual image looks to the vision tool itself. In some situations, it's important to use them, and in this example, we will actually be using them for the others. But start with the bottle because it's the simplest one we have. This is a white bottle. It's bright. What we're telling the count tool to do is find objects that are bigger than 20,000 pixels in size, that have a maximum size of 100,000 pixels, just in case it moves closer to the camera or further away from the camera. It's going to be a little darker or brighter, so we're giving it that big range of size. Telling it find things that are brighter than a threshold of 172. Now, the threshold itself is typically done by trial and error, by just seeing what is the biggest area that I can get out of this thing. And you can see how the bigger I make it, the more it's going to be more selective of the brighter pixels that I have. The more I bring it down, the more it's going to start finding everything. And since I made it real low at this point, it basically filtered out what came out to be more than 100,000 pixels, and now it's not finding any. So as I bring the threshold more towards where the bottle's threshold would be, so it doesn't find the background, we're at 177. It's finding most of the area of the bottle. It's finding this big blob, and it's passing because it's finding only one of them. So that verified the presence of the bottle. Let's take a look at this syringe. So this one is a bit interesting. This syringe has the tendency, as you guys can see, this is pushed all the way towards the back of the carton, but it has a lot of potential to move a little forward, to move a little back, to go to this side, unlike the bottle, which is pretty big. Look at this bottle, rolls over a little bit, we're still going to definitely see it. However, this syringe here is, this area that we can find is much smaller, and its size can change. But we need to be careful because the syringe is also white, which is the same kind of polarity we have with this big bottle. So I cannot just simply tell this tool to find white objects of a specific size, because within this area, maybe it's going to find this random part of the bottle. And that would be a false detection because I'm actually looking for this thing here. And it's not just a specific size, because if it moves closer to the edge of the box, it's going to be a little bigger. If it moves further in, it's going to be a little smaller. So the size here is really important, because if I say that it needs to be really big, it's going to start finding things that are related to the bottle. Or if it finds a little piece of the bottle, it might think that as well. So I'm not just looking for size here. I need to take into consideration the shape of this object. Now, what's cool about the syringe is that it's circular. And we have one of the morph filters in the filter operations that we have is a circle filter. A circle filter is used quite often, surprisingly, because whenever we have an inspection that is looking for vials, it's counting vials or it's counting bottles. These objects are primarily circular, and what the circle filter does is that it will have the tool, it'll change the image so that objects that are circular are very bright. What you guys see here is the image after the circle filter operates. What it does here is that it's finding all these objects that are within the circle, and the circle has a specific criteria of having, you know, this range of radius. So if it's within this range of the radius, the areas within the circle are going to be really bright. So what happens here is, this is what the Blob tool is actually seeing. It's not seeing what you guys are seeing in the carton. It's actually seeing this. And what we're doing here is that we're filtering out everything that are not circles, and they become much darker pixels than the center of the circle. And based on that, we're going to tell the tool to find these really bright pixels. So when I have a threshold here that is 236, that's close to the edge. It's close to the white value of 255. It's going to now find pixels that are inside that circle of the syringe. I'm giving it a minimum object size, a maximum object size. Obviously, that's really big, but I'm not worried that this value is really big, because in the end, what I'm looking at is something that is circular that looks like this. Anything else, anything coming from this bottle has such a different radius, so that this small circle area that the circle filter is looking for, that big bottle is not going to fit within that criteria, and obviously it's not going to find it at all. It's only going to be finding circles within this range, and it will highlight it in really bright pixels, and that's what this count tool is using to find this object, is really, really bright pixels that are higher than 236 gray points. And based on that, it's going to find within these two object sizes, it's got the expected object count as 1, so it's looking for 1 syringe. So if it finds it, it passes. Okay, I don't want to move forward until you guys are okay with this syringe inspection. How do you guys feel?
Where did you get that circle filter from?
Okay, so when you're in the count tool or the Blob tool, actually, there's always going to be in the setup tab or the segmenter tab a filters button. That button over here, it gives you the list of filters that you can add to the tool. Now, to add a filter, all you need to do is hit this button. This button over here gives you the list of all the filters that you can use. Open, it increases the size of dark areas, actually. Close increases the size of bright areas. And with these filters, some filters have settings. So if I use open, for example, and I hit OK here, I have these iterations, and based on the iterations, it starts changing the shape and the way these objects look to the tool. And that's how you add filters. I know I didn't probably go through that before. Yeah. And so with this particular syringe, we added the circle filter. We adjusted it so that it's highlighting really the center of that syringe. And typically you won't find that big of range. The range that you're finding here is that big because of the change in size that that syringe might have based on where it is in the carton. If it's too deep in the carton, it's small. If it's closer to the edge, it's bigger. So we need that range so that it covers the different sizes that the syringe might show up in. And the open filter is there so that it takes care of all the other bright areas that might show up by mistake. Because what open does is that it kind of, if there's bright areas that are not connected, it almost gets rid of them. So the good thing about that is that it's going to keep only the big portions that are connected together and create that blob, while other small fringe things will be it will get rid of them basically. Cool. And you can delete filters by hitting this delete button. So if I don't want open anymore, I can just hit this. The image is going to look like that. If I hit this on the circle filter, it's going to just show the regular image as it would be normally.
How do you add it back?
If I don't want to get rid of them, I can just hit cancel, and it won't save what I did. So if I want to add them back, let's say I hit OK. So I did all of these, and I hit OK. Now they're gone. Now I have to add them again. And obviously, now that I did this, it kind of shows what I was talking about. If I don't have the circle filter running, it might find just other things, like this random piece of the bottle, which I really don't want. So if I'm going to start over, I'm going to hit filters again. Let's say I'm going to add a circle filter. Here we go. I'm adding a filter, and I'm going to choose the filter that I want to use. Here's the circle filter. Circle filter, when you first choose it, it does look like garbage, like you guys see. This is garbage. One of the first things to do is the skip basically makes it skip pixels, and that really changes how long it's going to operate for. Circle points increases sort of like the resolution of the circles that it would find. So let's define that a little better, and then we can increase the dark radius. Here we go, and as you can see, as I'm changing this, the total area of the tool itself sort of decreases. The area that the tool can look at is not going to be the total area of the region of interest of the tool. It's actually smaller. As I increase this, it's starting to really, you guys see this really bright spot in the center. This is what I'm looking for. I'm looking for it to define that really bright spot for me. And what the bright radius will do is that it's going to make that bright spot a little smaller based on the actual radius that the circles that I'm looking for are supposed to have, so that it just doesn't find anything. There we go. I think that's similar to what we had before. I can't remember the actual numbers. Let's add the open filter again, and we have a similar inspection going on here. As you can see, this is the entire size of the count tool that I'm using, and this is the actual size after I ran this filter. So the filters actually change the overall size of the tool quite a bit. That's something to keep in mind. Okay. Any other questions? You guys opened up a pretty good subject when you asked me before. Anything else?
Nope.
Okay. All right. So with these two inspections, I was able to use simply a count tool because I know I need to find one bottle, I need to find one syringe. And if I find this, that proves that it's there. However, with things that cannot be counted, with areas that don't have a specific shape that I can look for every time, there is no way to do an inspection like this other than using the Blob tool. Now, this is a good example of this. This leaflet over here doesn't have a specific shape. And the problem with it is that it's going to look different every time. It's not circular. And the number of things that I can see out of it is not going to always be the same. There's some text, there's these horizontal lines that are coming that we can see based on how it's folded. So with something like this, what we typically do is use a blob tool. And this blob tool also runs with specific filters. Let me open this up. And let me open up the filters here. I'm doing the same thing like I did before. And this here is a horizontal edge finding filter. What you guys can see here is it basically finds the areas within its region of interest that are forming edges. Edges are basically going to be areas of, really changing contrast in a small area. And it's looking for horizontal ones. So what it's going to do here is really accentuate the folds in the leaflet because it creates horizontal lines. And as it creates horizontal lines, these areas in the folds are being picked up by that horizontal edge finding filter and turning these specific horizontal edges into brighter pixels. So what you're seeing here is a representation of all the horizontal edges that are in the region of interest. So if things are not creating horizontal edges, it's not going to find them. And so that's what it did over here. And then we're using the close filter to connect all those bright pixels together so it creates an even better signature. Now, and this is going to be the image that the Blob tool is going to be using. Now, obviously, what you guys are seeing here is a very weird thing. You're not seeing the actual image of the object. You're seeing the object as represented in horizontal edges, and we're kind of connecting the pixels that are creating those edges to accentuate it. And this is what we're looking at. So this area, if I'm trying to find this, I'm trying to find brighter pixels. What we have here is what the Blob tool will actually work with. I'm looking for bright pixels, and those bright pixels represent the signature of the presence of the leaflet. So I'll have it look for bright pixels, and the number of pixels that I'm going to find is always going to be different. The folds might not fall in the same spot every time. It might be turned backwards, so I'm seeing other things. So something like this, I cannot really, foresee how many blobs it will find and what is the total area of blob pixels that it will find. So in this situation, I can't use a count tool. Count tool will count blobs every time. Here I'm going to find a different number of blobs, so I cannot use the count tool, first of all. And I cannot use the blob count as the thing that can be used to verify whether it's there or not. I have to use total area. And what we're thinking about here is I've got a total area, and the tool actually displays what the total blob area that it found is and the total number of blobs. And I can't base the inspection on knowing what the actual value is. I have to use a range. And this is where that whole tolerance thing comes to mind. And the tolerance thing is in the constraints tab, where we're going to go over here and say, oh, I am using total blobs, but I should be using something else. Should be using perhaps total area and give it like a decent value of 2,000, perhaps 2,000. It's going to be a trial and error thing based on what is the total area that it's trained on and what is the regular total area that comes up when a leaflet is there. Now, obviously, something like this cannot be just figured out from one image. We typically run several images, see what the total area is, and put our constraints in the tool based on the total area that we find. So the values that I put in here may change. Let's take a look at a different image that has a leaflet. This one here is there without a bottle. The leaflet here is showing up, and the total area is 2,697. It's higher than what we saw in the previous image, which was about 1,400 or 1,500. Let's open another one that does have a leaflet. Here we go. This is 1,500 pixels. If we look at one without a leaflet, it doesn't have any total area, so obviously my constraint value here needs to be less. Let's make that 1,000. I'll have to retrain the tool, I think. Now, maybe I don't have to retrain the tool. One of the cool things about the Blob tool is that if you look into the performance view, Blob, I can take a look at the trained total area. The trained total area is 1,550 pixels. The trained total blobs is 3. So with these values that are just available in the performance tab, this is what the tool was trained on. I figure, you know, if the tool finds less than 500 pixels, it should fail, and if it finds, you know, a lot, that would be okay. So let's set our tolerances based on this. I'll say my constraints are the negative tolerance should not be 2,000 because that means that it's going to be around 0. If it's 0, it'll pass. If I'm saying around 500, I'm looking at a difference of about 1,000 pixels from the trained. I'm trained at 1,500. I want it to pass. If it's above 500, then my negative tolerance should be 1,000. Now it's failing. Now, if I want the positive tolerance to be a lot, because, you know, the more it finds, the more the leaflet is definitely there. So make this value really high. Now I'm using total area. Here we go. It's finding 0 pixels, which is really, really good at this point. One thing that it might find sometimes is the edge of the box itself, because that creates a horizontal edge right there. And it's finding like a little tiny blob of 12 pixels there, but I'm not worried about that. Let's go through all the images one more time. So here's an image where obviously this big count tool cannot find the big bottle that's supposed to find, and it's failing there. This blob tool is passing. It's got, you know, 3,000 pixels, and obviously that's within the positive tolerance that we have. It passes. This count tool found the syringe. Let's go to the next image. Next image, we don't have the leaflet. It's failing. It's only finding 12 pixels. That's below the tolerance that we gave it. This tool is finding a smaller syringe, and that's why we gave that circle filter a big range, because it looks different here. Obviously, this count tool easily found its bottle. Let's go to the next image. This one here is missing the syringe, can't find anything. This fails. And here we have this tool has got 1,600 pixels in it. That's very good. It's within the tolerances, so it passes. And here is the image with all of them in there, and they're all happy, and they're passing. How's everybody doing?
Just a quick question here.
Yes.
So for the blob tools or the count tools, you really don't need to press the train button. It's all in the settings.
The count tool doesn't get anything when it's trained. The blob tool, however, does work with training. So I didn't need to hit train here because I was able to see what the trained area was. But if you're creating the tool from scratch, it's not going to have any trained area in there, because the constraints in the blob tool work off of what it was trained on. So it was trained on a blob. It was trained on having a total area of, I think, 1,550 and a blob count of 3. If we go back to the performance over here, the counts, it shows here the trained total blobs and the trained total area, and this is the current tool's total area and the current tool's total blobs. So it's working off of what it was trained on, Finn. So it does need to be trained. However, I think it's really important for customers to know really not to train the tool, because let's think of a scenario. Let's say it was trained on these values, and then we set up the tolerances within the blob tool to pass and fail based on these values. So within these criteria, we know that this tool will pass if it finds a total area of 550 up to a total area of 6550, right?
Yeah.
Now, if I just all of a sudden like looked at this and I trained on this, now I'm moving around that value. If I train on this right now, what's going to end up happening? I just trained this blob tool. What's going to end up happening is that based on the criteria that I'm going to have, some other good images are going to start failing. So the math does get affected if you retrain the tool. So it's really important to be careful when you're training the Blob tool. It's not like an OCV tool where you can train on new characters and that's what the new model is going to be. This tool doesn't care what the object looks like most of the time, just looking at those two things that it finds, the total area and the total blobs. So it's really important to know what the math behind what makes it pass and fail is, and make the decision to retrain if need be, or to just change the tolerance values if that's what needs to happen based on what you see in the performance counts. Performance view, you can look at the Blob tool, you can know exactly what its trained parameters are. So obviously I need to retrain this to make it work. Right now, if I want to make this pass, I can either change my tolerance values or I can retrain it. And as long as the user understands what makes it pass and fail, they can make the choice of changing the tolerance if they want, or just make the choice of retraining if that's going to get them there faster. So, yeah, this is good. I'll retrain it on this. And it's going to be back to normal. But I could have just gotten the same results, again, by just changing the tolerances as I know what makes it pass and fail. That was a very good question, Finn. I'm very happy you asked that because that clears up a lot of things, and it's really one of the things that makes people really confused when they're using the Blob tool. That they go in here and they say in the constraints, all right, this is supposed to pass between 1,000 and 5,000, so I'm going to hit here. This is my lower limit. This is my upper limit. That's not how it works. And it's important to know that it's based on a tolerance, a difference between what is trained and what it can see. Very good. Fantastic. Okay. Let's take a look at a different example. Here we go. I think I have one that has a purple syringe. Okay. This one here is a little crazy because it's got the same bottle, it's got the same leaflet, but it's got a different syringe. And this syringe kind of doesn't have a shape. And you can't really see much of it. So it's really not very easy to deal with. Let me load the configuration that we ended up using here. Open tool group. Purple syringe. There we go. So what we ended up doing here is I did something really funny. I actually ended up using a count tool that's looking for dark areas, right? And I'm thinking, what the tool will see if the purple syringe is there is a whole lot of dark area that wouldn't be there if the syringe is not there. Sorry, the wrong thing. There we go. Something like this, where the total dark area that is found there ended up being smaller than what I have figured out through trial and error of what the minimum object size would be in a situation like this. And that's what I ended up using. So it's really, I'm not looking for the syringe as much as I'm looking for the effect that this syringe has on the image when it's there. And this syringe is significantly bigger than the other one, so if it's there, it's going to push this bottle towards one side. So if I'm concentrating on this area here, it's going to easily find this whole dark area. And since I'm not looking for a bright area as well, it's a little easier to deal with because I don't need to filter out anything that's related to the bottle. It's naturally filtered out because this is bright and this is dark. I'm using the same method, this same count tool that I'm using here, the same blob tool that I'm using here, that finds the horizontal edges. Sounds good? Okay.
Yeah.
Yep.
All right. Now I'm going to let you guys in on a little secret, which is it seems like this old crazy bug hasn't yet been fixed for the blob tool. Now, if you go back to the original example that we had, this is the case that Alexandra was working on. I think maybe, about a month ago for now. So let's take a look at the images that the customer sent in. Nope. Fig images. This is the fixed version of the inspection, but let me load the project file that the customer actually has. There we go. All right. What you guys are seeing here is that, can you see those little red lines on the blob tools? These are blob tools that are failing. What the customer was complaining about is they were saying, hey, whenever we start the system, the blob tools fail. What we do is that we take some of these tools, we move them a little bit, and they start to pass, and we don't want that to happen anymore because we don't know why. Now, what you guys are seeing here is that the blobs that these blob tools are finding are, there we go, you can't really see them. It's like a single pixel wide blob across the edge of the tool itself. Now, here's why this is happening. This tool is looking for dark objects, and it's running a threshold filter. Now, like any filter, what the threshold filter does is that it's still going to take it's going to take a piece of the region of interest of the tool and get rid of it. And what happens sometimes is that the blob tool will end up seeing a dark blob at the edge of the region of interest instead of just ignoring the whole area. This is really frustrating, of course. And what I got to see here in the customer's archive is that unfortunately the filter that's being used, the threshold filter, is really useless. What the threshold filter does is that it binarizes the images, meaning it will simply turn all the pixels that are darker than the value of the threshold to black and turn all the pixels that are brighter than the threshold value to white. The reason this is absolutely useless is because that's what this does. This fixed threshold is already doing this. The blob tool will take all the values that are brighter than this value and take them in if they are dark. And if I choose light on dark, it's going to do the opposite. So it's kind of crazy that this is even being used. I don't know who did that. I don't know if it's the customer. I don't know if it's our field engineer. But basically what ends up happening is that if we decide that we're going to look for dark pixels, what this filter is going to do is that it's going to turn anything that's darker than 40 into black. So this tool is going to find it anyway. So if I get rid of this threshold filter, and then I use a dark on light filter that is down to 40, I'm doing exactly the same thing that it was doing with the filter. The filter was basically just, showing us what it would find with a threshold of 40. So it was really annoying having to see that the threshold filter is really there for kind of display purposes. It doesn't have, especially if we're using a Blob tool, where its primary job is working with a threshold and finding everything that's darker than that threshold or finding anything that's brighter than that threshold, then the threshold filter doesn't have any value because that's what the tool does every time it runs. So what I ended up doing is just going through all these Blob tools that had thresholds and had threshold filters and got rid of all of these threshold filters and basically just ran it as is. So let me delete everything I have here. Let me load my nice new tool group. And all I did was just change those Blob tools that had a threshold filter, got rid of it, and ran them with the criteria that the threshold filter was running with. I basically changed the threshold to that same value, and based on what that tool was looking at in terms of dark on light or light on dark, that's what I ended up using. So this tool, for example, it's Blob white lane 6, so it's finding the bright object. It has a fixed threshold of 50, has no filters here. It has a pre-filter of 50 pixels. So if it finds anything that's greater than 50 pixels, that's brighter than 150 gray points, have a constraint of on total blobs, the positive and negative tolerances are 0. So if it finds anything, it fails. Now to verify this, I'm going to go to the performance view. I'm going to go to the Blob tools and see what the total trained blobs is. We should find 0 on all of these because these tools are supposed to find defects. This is what they're there to do. They're specifically finding defects. So their passing state is not finding anything. That means that it didn't find defects. That means that it passed. Cool. Okay. We also have count tools in this configuration. Where is it? There it is. There's the count tool, and this count tool is set up to find an object of a very specific size between 20,000 and 30,000 pixels. It's finding dark objects because, as you guys can see, this thing is pretty dark. And it has a threshold of 40, so anything that is darker than 40 is going to be found. So, exercise question. Who am I supposed to ask? Let's see, McCarl. If I bring that threshold lower, is this object going to be smaller or is it going to be bigger?
Lower.
It's a dark object, so, and I'm making the threshold lower. What was that you said? I'm sorry.
Lower.
Yeah. Is the object is going to get smaller, correct?
Yes, it's going to get smaller.
I think you are right, because what I'm doing here is that I'm making it more selective, so it's finding darker and darker pixels. As you can see, it's already taking away some of the area of that object because it's looking for these really, really dark pixels. So the object is going to continue to get smaller. Very, very good. Very good. As I make it bigger, the threshold is going to find brighter areas and start including it in that object, and as you can see, it is getting bigger. Well done, well done. So I'm bringing that threshold down. Now it's finding basically the outline. It's finding the whole area. It's not just the outline. It's finding the whole area, outline, and inside of that patch. Excellent. Now, as you guys can see, if we take a look at the entire image, the lighting is pretty even, but you can see how it kind of drops off on the edges where this area is darker, obviously, than what you see in the centers. So with this, the threshold values across the different lanes is not exactly the same. Some of them will be the same, some of them will be different. And that's why, for example, this Blob tool here has a threshold of 130 if it's looking for bright objects, while the ones in the center have a higher threshold because it needs these things to be brighter to get the same effect. Same thing probably we'll see in this count tool. Oh, well, the count tools are looking for really dark objects, so it looks like they can all work with similar values, but yeah, the center ones are brighter and the ones on the edges are darker. This is consistent with what we were talking about.
Would that be because the surface is not level?
I don't know if it's the surface not being leveled or it's the simple physics of, unfortunately, lenses. Lenses have something called vignetting, where in the center it will typically see more light and that kind of falls off on the edges. So it's a mix of the light not necessarily being as bright when you get towards the edges. Imagine that there's a backlight underneath these things. So near the edge of the backlight, there's going to be the border of the light. So that area is not going to be filled with light as much as the center areas where the focused area is going to be lit up, and the areas to the right and left of it will also be lit up. The more you go towards the edges, the more the end of the light is going to be there. So you're going to be getting overall a little bit less light, which, you know, to get over that, we use longer lights. We use lights that are a lot bigger. And also there's hardly anything that we can do when it comes to the lens vignetting other than closing the f-stop of the lens, which kind of plays a part in decreasing that effect a little bit, but it doesn't get rid of it completely. Yeah. Excellent. Are there any other examples of use of blob in count? Yeah, I think I have one more. Let's see what other examples I have. File count. Do you guys want to take a look at color for a little bit? Since we're in the subject of doing count inspections. Let me also show you that, because we do that on occasion, and Genzyme did something like that earlier this year, I believe, or late last year. Let's change this to be a color station. Here we go, here we go. Let's open those color images. That will show us a little bit of color, and it will also show us the count tool being used to count objects, not just to verify their presence. The file count. Let's take a look at the orange ones. There we go. Yeah. Okay. Set the image as is. 96. Image test. Okay. So here we have an inspection where we have 200 orange vials in a case. The lighting for this is a little exhaustive. We have two lights close to the camera. They're doing a crossover thing, doing an X shape basically. So one light is illuminating the area on the opposite side, and the other light is illuminating the area on the other side. And the reason that we use color in situations like this is because with the different vial colors that we have, the black and white contrast might not be as good, but when you're using color, you're using color. There's a difference between that. So especially with the example that we have here, orange, if we switch this to black and white, basically there's not going to be any contrast almost between the orange and the color of the cardboard. When we use color, we can see it. So in order to do an inspection like this, and I'm just going to go ahead and do the whole inspection for you guys so you guys can see what's going on. In an inspection like this, this is not exactly a color inspection because in here it's not like we're trying to find whether there is the wrong color vial in there. We're using color to enable us to do a count inspection on these vials. So this is really a combination of color and black and white tools working together. What we do here is that we train a color tool on the shades of the colors that we're trying to find. So in here, what I want this color tool to do is highlight all the pixels of the orange that I need to look for. So what the color tool does is that you draw it on an area that includes the color that you want and train. What it did is add all the colors of the pixels within its region of interest to its color bucket. Let's call it bucket. So any pixel that matches the color that it's been trained on is going to be highlighted. So as you can see, it's not finding all of them because there's a difference between most of the orange that you see here, for example, this, which is a little darker. So in order for me to add those colors, what I do is I go to a different area that has a different group of colors in it, and I hit stat train. That added those colors that are in this area to the bucket of colors that I had. But again, that's not enough. There is a little trick that we can use with the color tool where it works in different modes. Trained color area is a mode where it's going to find the specific colors that were in the pixels that it was trained on. There is foreign, which is going to make it find all the other colors, so it's basically going to be kind of like the negative image of that. Closed color area is going to find the area, the colors that are kind of similar to the colors that are trained. So with closed color area, I have the slider which I can change the threshold, and it will automatically go to the areas in the color histogram that are similar to the color that it was trained on. Now let me show you something really cool. The color histogram is this really cool tool that we have that shows us what the color tool is looking at. If I uncheck train, basically these are the colors that the tool is currently looking at. And as I change, hang on, as I change the threshold to be more, it's going to take away from the area that, oh wait, I need to include the trained. All right, it's going to take away from the area that was trained, and if I make it lower, it's going to basically add all these other neighboring areas in that color histogram to the set that it's looking for. So what we typically do is that we train some of the colors, some of the main colors, and what we do is that in order to include all the other colors, we use closed color area, we change the threshold, and then we look at the displayed pixels. Displayed pixels are to our liking. What we do is that then we use this particular button here, which trains only the highlighted pixels. So what it does is that it's going to take all the color content from the pixels that are currently highlighted and make those the trained color set. So what I'm going to do is I'm going to hit this button, and then I'm going to go back to the trained color area, and now the area that is trained is exactly what I intended to be. So I have here a color tool that's finding the exact colors that I need. All I need to do now is have a tool that's going to just go in and count these objects. So how about a count tool? Because we're counting. So here we go. You can lay the count tool inside the blob tool. What the count tool is going to see is going to be a representation of this color image based on the criteria of the color tool, where it's going to see those trained pixels as bright pixels and the untrained pixels as black pixels. If I take a look at the filters here, This is the representation of the image in black and white based on the criteria in the color tool. So all these orangey things are bright, everything else is black. All I need to do is just give it my minimum object size, my maximum object size, and expected object count. I think I have 200 of these in here. What's my minimum object size? Let's say 100. That's too big. 50. Nope. 200. Oh, I need to look for light on dark. What am I doing? Yeah, there we go. Everyone makes mistakes. All right, so light on dark. Now it's finding 200 different objects. I haven't yet figured out what the minimum object size is, but it seems like 350 is a little too high because we got rid of one, got rid of this one, which ended up being a little smaller than the rest of them. Let's see, 250. Now let me show you one other really cool thing the Blob tool can do. So I have this count tool. This is already fine. It's working this way. One thing that the Blob tool does that the count tool cannot do is analyze those blobs. So I'm going to set up a Blob tool that has very similar criteria to finding these blobs. The Blob tool has different methods, just so you guys know. We typically use fixed. Fixed works off the regular scale of 0 to 255. So it's very easy to kind of set it up around that. Threshold we had in the count tool is 128, so let's make that 128. We said that the minimum object size in the count tool was 250. Let's say the maximum is 1,000. Now it's getting us the same exact result. This is really what the count tool does. It takes specific things that are in the Blob tool, and it creates it, and it finds the objects accordingly. Now what the Blob tool also does is that in the Stats tab, you can actually go through all the different blobs that you have, and it will give you all of these statistics on that blob. It tells you what the angle is, what the area is 514. Now we know what the area of the blob is. Has a perimeter in pixels, which is, there's the perimeter. Elongation is the ratio between the long side of the bounding box of the blob and the short side of the bounding box of the blob. So the more the object is square or circular, the more this value is going to be closer to 1, because it's going to be the same ratio. The more rectangular it is, the more this is going to be closer to 0. So if we click on all blobs, it will actually give us the minimum, average, and the maximum for all of this. So if we want to find sort of what is the ballpark for the blob size that we have for this particular inspection, we can take a look at the area, and we can see, okay, the smallest one is 281 pixels. The biggest one is 654. Our average is this. So if I want to create a count tool, I kind of know where my boundaries need to be. Maybe I need to make this, 200, so that if the thing kind of moves a little bit or doesn't have the exact orange that that the color tool is looking for, it can still find it. I can say that my maximum needs to be above, 700 or 800, and then run some tests and make sure that I'm finding everything. So if I get rid of this Blob tool, now I can set up this tool according to known values. Now let's take a look at the other image. There we go. We took these two out. Now we're counting 198 pixels. So, important thing about setting up such an inspection is to have very good color training to make sure that the colors that the color tool is finding is really a complete set of colors that correctly represents the vials that are in the case. Once I get that done, I can run my count tool or Blob tool reliably.